Hi everyone, and welcome to this lightning talk, Helpful Tips for Building a Text Classification Model. I just want to say thank you so much to everyone for joining me today. I know that it's quite late and it's a Friday, but just a small thing. If anyone's planning on having a nap, just make sure your mics are muted. No, I am just joking. I do really appreciate everyone being here today, and I really hope that you are going to find this interesting and also hopefully take away something about text analysis. My name is Brittany Wagenaar, and I'm a data science associate at Luno. I work with the customer success data, which includes quite a significant amount of text data. Some of my work in the past has included text clustering to find hidden problem groupings amongst text, as well as doing a sentiment analysis on customer messages to see how their sentiment changes over time. But most recently, and probably most excitingly, I've been working on a text classification tool that can take the first message a customer sends us and categorize it into one of our primary customer contact drivers. Now, I've been working on this text classification tool for a while, which means that there are just naturally some things that I've picked up along the way that I think are helpful to share with other people to help them with their text analysis endeavors. So for this talk, I'd like to go over and just recap the concept of text classification. And then I have 6 tips that I'd like to share with you today, and they can fall nicely under different parts of the model building process. So we have data understanding tips, data preparation tips, and results analysis tips. I'm not sure that we will have time for questions today. I do have quite a lot I would like to get through, but I'd like to encourage anyone to reach out to me either via LinkedIn, my name is Brittany Wagenaar, or via email. Okay, so let's get into it. What is text classification? So text classification is the process of categorizing text into organized groups. This is often achieved using natural language processing, or NLP, where text classifiers can automatically analyze text and then assign a predefined set of categories to it based on its content. So text classification is often used in SEO optimization. It's used in quite a lot of customer relationship management tools, often used for sentiment analysis and opinion mining. And honestly, it is transforming the way we're able to think about and work with our text data. So there are new use cases being thought of quite regularly. Now, before we can move on to our tips, I do feel like it's my data science obligation to talk about the first part of the model building process, which is understanding your data. So data understanding refers to all the activities that you would do to get to know your data. At this point, you should be asking yourself if the data you have collected is relevant to your problem. If it's not, throw it away. It's not going to help you. Find something that is more useful for your use case. But if it is relevant to the problem you're solving, then you'll probably start looking into the fields of your data set and trying to understand them. Maybe you'll start looking at how they impact your dependent variable and maybe what their distributions look like. It's also at this point that you'll start to consider how to handle the data. If there are missing values, you'll consider what you can do to fix that. And if there are duplicate rows, what you'll do to solve that. And if you need any feature engineering to enhance your data set, this is really where you'll start thinking about that. Data understanding is a really, really important part of the model building journey. And if you take a proactive approach to this, then you'll find that your model building journey will become streamlined and efficient. However, if you are more reactive to understanding your data, you might find that your journey becomes quite jagged, and sometimes it can also be disorganized. All right, so now we know the importance of understanding our data. This means we can go on to our first tip for the day, which is use suitable data. Now, This might seem a little bit obvious, but any machine learning application, and especially text classification applications, are only ever as reliable as the data that they were built on. So, for example, there are many online tutorials that show you how to create sentiment classifiers. And a lot of these online tutorials are based on Twitter data, where tweets are labeled as either being positive or negative. However, these classifiers are really only good and they're only suitable at classifying similarly structured data. So if you took one of these classifiers and you try to use that to classify your own, maybe less colloquial and more objective data sets, you might find that the classifier struggles to do this and struggles to categorize this, and you may get less convincing results. So yeah, if you tried to do this on, let's say, a newspaper article data set, and you tried to classify whether the articles were positive or negative, you might not be that happy with your results. The takeaway here is really that if you're going to build a text classification model from using online data, and especially to try and apply it to your own personal data, try and really look for an online data set that mimics the structure of your data set. You'll likely find that the results you get are going to be a lot more useful and the insights are going to be a lot deeper. Okay, well, now that you have taken the time to understand your data, you can move on to the next phase in the model building journey, which is data preparation. And the data preparation phase of the model building journey is by far the most time consuming. And this can very easily take up to 80% of your entire model building journey, maybe even more. It's unsurprising then that most of our tips are going to fall under this data preparation phase. It's in this phase that we are going to try and transform our data and get it into a state that's easier to handle and easier to fit a model to. Text data specifically is extremely dirty and rough and unstructured. I mean, that's why we love it, but we do need to do quite a lot of text preparation and data cleaning here to get it into a way that we can eventually fit a model onto it. With the key takeaway being we can't lose or change any of the information. So we basically want to take our large unstructured data set and get a subset of context-rich, like data beautiful, like a beautiful data set that we're going to use. So this brings us on to our second tip for the day, which is create an exhaustive stopword list. Now, language, as beautiful and complex as it is filled with words that have like no meaning or no value to the meaning of a sentence. These are called stopwords, and they are words that don't add significant meaning to a sentence. If you remove them, you probably wouldn't even change the meaning of a sentence. So these are your words like your prepositions, your pronouns, or your articles. And although they can help with the general clarity in a sentence, they won't carry a lot of meaning on their own. I can guarantee you that any NLP tutorial you find online will definitely have a section for removing stopwords. And there are a lot of libraries in both R and Python that you can use to do this. However, the tip here is to create your own list of stopwords and then append it to whatever removal package you're using to create a more exhaustive list. So if you take time to really understand your data, you might find that some words just appear more frequently given the context, and they might not necessarily add any additional value. So for example, you can think about a customer service data. You might find that company names appear more frequently in customer service data, but although the customers are referencing the company name, that company name is not really helpful in determining the problem the customer is trying to describe. So it may make sense to remove it. If you're looking how to create your own custom stopword list, what I'd suggest that you do is first use a standard package and remove all your stop words from your text corpus. Then make a word map of the most frequently occurring words that are left in your dataset afterwards, and just do a visual check. Check that all the words there would make sense and probably would give context based on your use case. If they don't, add them to your custom stop word list and remove them. Okay, so now that we have removed all of our stop words, we can move on to another data cleaning step, which is called limitization. And this is really what tip number 3 is, that limitization is key. So earlier we mentioned how part of the text preparation process involves transforming data while making sure that we don't lose or change any of the information in the data. So something to consider here is, how do you handle words that mean the same thing, but are represented by different parts of speech? So consider the following words: love, loved, and loving. All these words at their root word mean love. And in text analysis, to group like terms, we would want to consider all the inflection words of a word as being the same thing, which means that instead of having multiple representations for the same word, we want to transform it to its root word, and we only want to consider that. Now, most NLP tutorials you'll find online will probably have at least one method for you to do this, and it will either be stemming or limitizing. Stemming is like chopping the end of a word off. It's very quick, but it's super reckless, and sometimes the results don't even make any sense. It is quite quick to do this, which is the only reason I think people actually still use stemming. Limitizing, on the other hand, tries to convert a word to its root form and can be utilized with part of speech tagging. And it can do this, if it is utilized with part of speech tagging, it can make a much more intelligent transformation to a root word. From my experience, limitization is not actually it's not significantly more time consuming than stemming, but the results are always far superior. I mean, we can have a look at the words on the screen right now. The words went, octopi, organizing, and worst. If we look at how stemming was able to transform those words to its root word, well, went, octopi, and worst were not able to be transformed to a root word. They actually stayed exactly the same. And frustratingly, organizing was converted to the word organist. That's extremely frustrating in text analysis because we would expect the word organizing to be transformed to the word organize. Organist and organize would still be seen as two different terms in our text analysis, so actually that wasn't helpful at all. If we look at limitizing, we can see that the word went was transformed to the word go. Octopi was identified as the plural for octopus. Organizing was converted to the word organize, and worst was converted to the word bad. In general, limitization is a much more sophisticated approach to creating like terms. And there are a lot of packages that you can use to do this easily for your data set. But the key here is always limitize, don't stem. You'll be happy about it because your results will be better. Okay, so now that we've spent some time limitizing and cleaning our data, we now need to represent our text data in such a way that a machine learning algorithm is able to understand it. Which brings us to our fourth tip today. Spend time on choosing your text representation. Now, there are a plethora of methods to represent text numerically. You have some more simple approaches like a bag of words model that represents words based on the frequency in which they occur in a text observation. And then you get slightly more complex representations like word vectors that try to capture a semantic relationship between words. In general, any method that tries to capture a semantic relationship is probably going to yield better results, but I would recommend that you take your time and research a few methods. Also, don't feel afraid to try a few before you end up committing to one. Okay, so now we've finished preparing our data and we have now represented it in such a way that a machine learning algorithm would be able to understand it. Our next step in the model building journey would be splitting our data into a training, a test, and a validation set so that we could build them, so that we can use that to begin building our model. This brings us to tip number 5. Understand the distribution of your classes. Now, as with any machine learning application, finding a balanced data set is unlikely. Some classes can appear more frequently, while others hardly at all. Sometimes the imbalance of your classes can cause tendencies for your ML algorithms to favor classifying to the class that's most commonly represented in your training data. Obviously, that is undesirable, and there are ways that you can mitigate this risk. One of the simplest being sampling your training and test sets in proportion to the population, also known as stratified sampling. Stratified sampling ensures that each subgroup within a population receives a proper representation within the sample, and it helps ensure that no one class is ever over or underrepresented in the training set. This is really important to remember because this gives your model a fair chance to find and learn patterns in your training data that would mirror their population. Okay, now this brings us to our final tip for the day. Sad. Which has to do with the results analysis and what you can do when your results maybe aren't as convincing as you hoped. Be creative with your evaluation metric. Sometimes when we solve a classification problem with multiple classes, our classification results are not always as impressive as we hoped when we set out to build the model. This could require us going back to the text cleaning and tweaking a few things, or maybe getting more creative in our feature engineering. But this could also just mean that we need to look a little bit deeper into our results. So I'd like to suggest that the next time you face this classification problem, to try plotting the confidence score distributions for each one of your classes, but split that by correctly classified observations and incorrectly classified observations. What do those confidence score distributions look like? Are they similar, or is there a notable difference between them? And if there is a difference between them, is it possible that you could utilize a threshold before making a prediction? Setting thresholds can really improve the accuracy within your classes by making far fewer incorrect classifications. As you can see on the screen, if we look at the correctly classified observation group, we can see that it had a median value of around 95%. Whereas when we look at the incorrectly classified observation group, it had a median value of around 75%. It was possible here to utilize this 20% difference in the medians and create a threshold at around 85% before making a prediction. This drastically improved the accuracy within this class by making fewer incorrect classifications and overall ended up with a much better recall score for this class. If that was just a little bit confusing, the takeaway here is to consider how detrimental it would be if you make a false positive or a false negative prediction. Really take time to consider your use case and who would be affected. For example, in the case of medical testing, getting a false positive may mean misdiagnosing someone with an illness they don't have, in which case that the cost of making that false positive prediction can be quite significant. But this point really rides on the earlier one of taking time to truly understand your data. And in addition to that, understand the problem that you're trying to solve. Wow, everyone, can you believe that we've just gone through 6 helpful tips for text classification in 20 minutes? I just want to say thank you to everyone being here today. I don't know if we have any time for questions, but you are welcome to message me on LinkedIn at Brittany Wagenaar or via my email address, brit_432@hotmail.com. And I would just like to put a little disclaimer out there. I'm fully aware that no one uses Hotmail in 2020 anymore, but I've had this email address forever and I'm probably not going to change it. So for the people on the other side of the computer going, oh, this girl still has Hotmail, I'm fully aware that this could be seen as a little bit cringy. Anyway, thank you so much, everyone.
No Nigerian princess here. But yeah, thank you so much for the amazing talk, Brittany. It was absolutely amazing. I do have a bit of a question. It's a quick one. What would it look like using something like AutoML? Have you played around with it? And what would that look like, especially when it comes to the Google tools that are available? What would that sort of entail?
I haven't really played around with AutoML, but I could really look into that maybe even later today or over the weekend and get back to you. My text classification tool that I worked on was predominantly in just like on a local computer in Python and utilized Keras and TensorFlow packages.
Okay. No, thank you for the awesome talk. It was really, really amazing. And I hope a lot of our viewers took away something. And it was amazing again. Thank you.